I'm about to show you how to calibrate your computer monitor. Many monitors work well straight out of the box, but if you find that your prints look wildly different to how they look on your monitor, or that your digital images look different when you view them on other people's equipment, it may well be that your monitor needs calibrating. In this example of a poorly calibrated monitor, the image is displayed with a blue tint. And the problem is, when we come to edit the image, we're likely to increase the white balance to compensate for this blue tint. When we then view the image on a correctly calibrated screen, it will come out looking too warm or red. Another way in which poor screen calibration can show is in an inability to show a full range of tones. On this test card here, you should be able to see the difference between all the squares, and especially from the 0 and the 1 at the shadow end in the top left to the 1 and the 0 in the highlight end at the top right. In this example though, which illustrates how a badly calibrated monitor might look, we're unable to distinguish the squares at the top left and the bottom right from their immediate neighbours. This would result in our monitor showing images without detail in the bright highlights and dark shadows. So if you've decided that you're going to need to calibrate your monitor, you're obviously going to have to go out and buy or acquire some sort of device for doing that calibration. And the first thing you need to know is that not all of these devices are equal. This Spider 3 device used to work perfectly well on my old computer, which had an LCD screen with CCFL backlighting. However, it doesn't work at all on my current computer with an LED backlit display. So we'll get rid of the Spider. So for this demonstration I'm going to use my X-Rite i1 Display Pro colorimeter. And all I'm trying to say here is before you go out and buy a device, just make sure that it's suitable for the sort of display that you've got on your computer. What we're going to do next is look at what's in the box. And there's two main parts to the colorimeter. There's a software installation disk and the colorimeter itself. To remove this cover, you'll see that it actually has a lens which covers the actual sensor element of the device, and obviously there's a lead that allows it to connect to the USB port of the computer. The principle behind which the colorimeter works is that we install the software on the computer and then connect the colorimeter sensor to a USB port. When we run the software, it sends a series of swatches or patches of a known colour and brightness to the computer screen. The sensor measures the output from the screen and reports information on this back to the software. The software then compares the information it receives back from the colorimeter with the information it knows it should be receiving to decide whether the screen needs any adjustment. If adjustment is needed, the software creates an ICM profile which compensates for any inaccuracies in the display. So let's see how this works in practice. We've installed the software. We can connect our colorimeter. But there's a couple of other things that we need to ensure before we start calibrating. First of all, we need to make sure that our screen is clean, that there's no grubby finger marks or dust on it. So I'll give it a wipe down with this brush. And secondly, it's essential that both the screen and the colorimeter are fully warmed up. The screen, for example, won't reach its full operating brightness till it's been turned on for 30 minutes. So we've had everything turned on for 30 minutes and now we're going to run the software. And this is the home page on the i1 Display Profiler. There are two ways of running this software, in the basic mode or the advanced mode. I'm going to do this demonstration in the advanced mode just because there's a couple of settings that you need to be aware of. Down the left hand side we've got a number of options to allow us to pick whether we want to profile a display, a projector or a printer. But we're going to profile a display. And that takes us to this screen, which, as I've said, gives us a few options. It's identified what sort of screen is connected to the computer, my Dell U2413. This drop down box allows us to select the correct sort of technology of the screen's manufacturer. As I said earlier, some older screens have CCFL backlighting, but this is an RGB LED screen, so we're going to select that. White point. This is to set the white point of the lighting conditions in which you're likely to view the screen. Most people think that daylight colour temperature, 6500 Kelvin, represented here by D65, is a suitable setting. It certainly works for me. Some other people prefer settings between 5500 and 6500 Kelvin. Next is the luminance of the screen. This screen is actually capable of giving a luminance of up to 400 candelas per metre square, but that's far too bright for photo editing. Recommended settings are between 90 and 120 candelas per metre square, so I've set this to 120. The contrast ratio of the screen, well, it works best if you leave that at the native setting for the screen. And we've got two boxes down here for flare correction and ambient light control. Flare correction I'm not going to bother with, that's talking about correcting for light that might be reflecting off the screen while you're trying to calibrate it. Really, you shouldn't have your screen in a position where there's a light source falling directly on it, so I'm leaving that turned off. And ambient light control, what this does is after you've calibrated the screen, it uses the colorimeter as a light sensor in the room to alter the brightness of the screen dependent on how bright the lighting conditions are in the room. I preferred not to use this feature because I don't really know where I am. I don't know if I've altered the screen or the computer has, so I just make my own manual adjustments if I feel I need to. That's it for that page. This page concerns us with the actual ICC profile itself. That's the International Colour Consortium profile. This is the piece of software that the X-Rite software creates to modify the output to your screen. The chromatic adaptation setting is best left to its default, which is the Bradford setting. If you're wondering why Bradford, that's something to do with the computer monitor factory that was there in the 1980s that created a lot of the standards in this field. The ICC profile version, there's two commonly used versions of the ICC profiles, version 4 and version 2. Although version 4 is the more up-to-date, it seems to create problems on some screens and computers. So I prefer to use version 2, never had a problem with that. Tone response curve, again the default on this is gamma 2.2, and that seems to work with most modern computers. It's certainly the default setting for Windows, and I believe it's now the default setting for recent Mac computers, although some older Macs work on 1.8. The profile type is just about the way the software actually creates the profile, and leave that on the default matrix based setting. So basically, although it's starting to look complicated, all these can be left to the default settings. The only thing you might need to concern yourself with is the ICC version. If you try and do this profiling in the basic mode, it will set the ICC version to 4 and you may have a problem. If you do have a problem, come into this mode and change that to version 2. So we'll move on to the next screen again, and this is just showing us all the different patches that the software is going to send to the computer screen to create the profile. We've got a choice of using a small range of patches or a large range, but the small range has always been good enough for me. So we'll move on again. We can see that the software has detected our measuring instrument, the I1 display, but there's two other ticky boxes down here under display hardware setup. And what this allows us to do is to optimize the actual settings of the screen itself with the screen brightness, contrast and color controls before we take the measurements and create the ICC profile, which can give us better results in the long run. If you have a very basic screen with no controls on, just leave these unticked, but some displays actually have automatic display control where the software can interact with the screen via a USB lead and make those adjustments automatically. In this case, I'm going to tick adjust brightness, contrast and RGB manually. So let's click on Start Measurement, and we get a little dialog box in the left hand corner. There's three ticky boxes here for contrast, RGB controls and brightness. If your screen doesn't have any manual adjustment for these features, leave them unticked. If you've got a laptop, it will probably just have brightness control in the power settings, so you could tick that one and leave the others unticked. Because this particular screen has manual control of all three of these, I'm going to tick all three. The box is also asking that we place the measuring device over the centre of the screen. It's important that we get it in the centre of the screen because the screen output can vary around the edges, and it's also important that it's flush against the screen so there's no light leaking in around the edge. Another thing that's important at this stage is to do a factory reset on the screen, so I'm just going into the screen zone menu, and that's resetting all the monitor's parameters back to the factory settings. So we can click next, and the software starts to send the coloured swatches to the screen. This first part of the routine though is just concerned with ensuring that the red, green and blue settings on the screen itself are correct, and the display in the top left hand corner here shows that they're all correct, and it's telling us that we've got a target colour temperature of 6502 Kelvin, and it's actually running at 6475 to 80ish, which isn't bad at all. So I'll click next again, and it'll now start to look at the brightness of the screen. And that's showing us that the screen is way too dark at the moment. The target white luminance is 120, but the measured luminance is only 53. So I'll go into the screen settings, and make the screen brighter until I get that orange mark where we want it. I would appear that the closest we can get it is 112, so we'll go with that. And click next again, and the software is now actually sending the colours to the screen that it will use to create the ICC profile. This is going to take a couple of minutes to run, so we'll fast forward this bit and move on to the next stage. So the software is now finished running the series of swatches, and we can remove the colorimeter from the screen and click next again, and next again, and it takes us through onto the screen where we can create our ICC profile. You can see that it's entered the name of the monitor up here for the profile. I like to give that a date so I don't get it confused with previous profiles, so I'm going to call that _115 for January 15. Click create and save profile, and that's it. This monitor has now been calibrated. We can actually see here in the results that the white point, we set it to D65, and it's actually achieved a white point of 6543 Kelvin, so it's 43 Kelvin out. The screen luminance is spot on at 120 candelas per metre square, and the contrast ratio has come out at 910 to 1, which is pretty good really. One final thing we can do is have a look at our monochrome test chart, and we should be able to see a clear difference between these two squares in the top left of the image and these two squares in the bottom right. I can clearly see it on my monitor, but if you cannot see a difference between this square here and this square here, or you can't see a difference between this one here and this one here, it means the display you're watching this film on needs calibrating.